Hello, I'm going to discuss my solution to today's challenge in October LeetCoding Challenge. I'm Channa Bankapur and I'm recording this video for our YouTube channel, GoMaster Coding Interviews. Please do subscribe to it. So today's problem is rotate array. It's about rotating an array by k steps to the right side of it, right? So a simple example is good enough to understand the problem. Suppose we have like 7 elements as given in the problem and in the sample test case here and k equal to 3. That means every element is going to go or move by 3 steps to the right side. So one is going to go to the fourth step, fourth place, which is in the, and then two is going to go to fifth place and so on, right? So the last k elements are going to wrap around and then come to the beginning of the array because it's about rotation, right? So to generalize this one, I'm going to have something like this. Say we have some elements here, n elements here, and normally we index them as 0, 1, and so on up to n minus 1. So suppose if there is a at the at position or index 0, it has to move to position k, right? So because that is k steps away. So a is going to go to kth position. And similarly, if b is at index 1, b is going to go to k plus 1, right? This is k plus 1, and so on, all the elements. But what is that last element that goes to n minus 1 position, right? So this element, suppose if it is c, what if the destination position is n minus 1, this position has to be something like, n minus k minus 1. So this is the position that is going to go to n minus 1. But what about some element, say d, which is present at n minus k position? So that cannot go to index n, which is out of the array. So that is going to wrap around and then come to location 0 or index 0. Similarly, the one which is following d, e, is going to go to index 1. And so on. The last one, whatever is at, say, suppose f is there at location or an index n minus 1, that's going to go to k minus 1, right? So this is k minus 1 here. And that's how everything is going to rotate essentially, right? So this is what we need to do. Let's try to come up with a method of doing this one, because we already know how to do how it looks like when you turn it around, when you rotate everything. So I'm going to take this similar idea here. Suppose we have elements like a, b, and so on up to c here, and then at starting from n minus k, this is 0 here at a, and we have d and e and so on up to f. F is at location n minus 1. So this is how we have a setup here. Obviously, there are a bunch of elements here. Now let's see how to basically transform this whole thing into a rotated array of by k positions. So think of just reversing the whole thing. Let's see what happens. If you reverse the whole thing, it's going to look like this, because everything is going to go swap. The first and last element is going to swap. So F is going to come to this place, and then uh, things are reversed. So we're going to have E then followed by D here. So that is going to be the first K locations right here, 0 to K minus 1. And starting from K, because it is reversed, C is going to be here, and then and so on. And finally, B and A, right? So A is going to be the last position, which is n minus 1, because that was at 0 in the beginning. So, but this is not the exact rotated version. But if you look at the block sizes, they are actually almost, because the last k elements were supposed to come to the first k elements, and they are actually now, if you look at it, but they're in the reversed order of that. And the first n minus k elements, which are a, b up to c, should be in the last n minus k positions, which are there in their positions in that sense, but they are in the reversed order. So if you reverse these two blocks by themselves, so suppose if you reverse the first k elements, you're going to get something like this: d, e for up all the way up to f. And then if you reverse the next n minus k elements, you're going to have a, b all the way up to c. See, this is exactly what we needed. This is the rotated version of the original array, right? So all we need to do is this: reverse the whole array first, and then reverse the first k elements, and then the remaining n minus k elements. That's going to give me the answer. So let me show my code, which is very simple to understand. So look at this. What I have done is I have taken so this one case I have taken out. If k is greater than or equal to n, or if then we are going to just take the mod value. so that it's basically a cyclic thing, right? If you rotate by n positions, you're going to get back to the same thing, right? So that's why k is always k mod n for us. And if k is 0, we don't have to rotate anything, so I'm going to just return, right? Otherwise we need to do this rotation. So the first rotation is going to be rotating the whole array 0 to n minus. I'm giving the range here, and then I'm going to reverse the array from 0 to k minus 1. Those are the first k elements, and then reverse the remaining n minus k elements starting from k all the way up to n minus 1. So how do we reverse an array given a range I comma j? We know this one already. So we have two pointer approach. I is pointing in the beginning of the range, j is pointing at the end of the range. We keep swapping ith element and jth element. So these three lines are going to swap ith and jth element, and then we increment I and decrement j. So that way, when they come and approach, if they're equal also, there is no point in swapping because it's the same element. So as long as I is strictly lesser than j, we keep doing it, right? That's going to reverse it. All right, so that should work. Let's see whether it works for the sample test case. Yes, it worked. Let me submit it, and it accepted, right? So it's a very easy solution. There are other solutions which are also good. If you look at the time complexity of this, this works in linear time, because look at, we have say size n here, and this reversing is of n elements. So if you look at here, this takes linear time, linear to the size of the range, which is j minus I plus 1 in this case. And that's why this is going to take big of n operation. And then these two put together, if you see both of them, one of them is of size k, another one is n minus k. So put together it is linear. So I'm going to say the whole thing is linear. So linear plus linear is all just linear. So that's why the overall time complexity is linear. And it doesn't take any extra space. That's why it works in big O of one extra space, right? So this is the best we can at least ask in terms of asymptotic complexity or big O notation. And I think this is good enough. But there are other solutions which are equally good, or some of them are maybe a little better in terms of improving the tuning the performance. But yeah, let's not get into that. If you know any method, let me know in the comments below, right? Please like this video and subscribe to the channel, and keep coding. Thanks for watching.